It's a mind-boggling thought, isn't it? Humans measure time in seconds, minutes, hours, and years, but 10 quintillion years stretches far beyond our ability to comprehend. That's 10 quintillion years, a length of time that dwarfs even the lifespan of the universe as we know it. But what would you find if you could travel that far ahead? Would the universe even exist? Would there be stars, planets, or life? Let's dive into this cosmic journey and uncover what science suggests could await us in this incomprehensibly distant future. First, let's set the stage. Our universe is approximately 13.8 billion years old. By the time you hit the 100 trillion year mark, all stars will have run out of fuel and ceased to shine. This period, called the degenerate era, marks the end of stellar activity. Without stars, the cosmos will be cold and dark. White dwarfs, neutron stars, and black holes will dominate the landscape. Occasionally, two white dwarfs might collide, creating a brief spark of light. But these events will be rare, and for the most part, the universe will be a silent, frozen expanse. By 10 quintillion years, even these remnants will have evolved into something even stranger. Over trillions upon trillions of years, black holes will continue to devour matter, growing larger and more powerful. However, even black holes have a lifespan. Thanks to a phenomenon called Hawking radiation, black holes slowly lose energy and shrink over time. While this process is unimaginably slow, it means that eventually even the largest black holes will evaporate. By 10 quintillion years, almost all black holes would have evaporated into faint wisps of radiation. The energy released would disperse across the universe, leaving behind an almost completely empty and featureless void. This stage of cosmic history is often called the black hole era. But by our target year, even that era will have ended. So, what's left after black holes? The answer, not much. The universe would have reached what physicists call heat death. In this state, all matter has been broken down into its most basic components: protons, electrons, and photons. These particles drift endlessly through an expanding, cold, and dark universe. It's worth noting that even protons, the building blocks of atoms, are not eternal. They're thought to decay over time, with an estimated lifespan of at least 10 to the 34th power years. By 10 quintillion years, most protons will have disintegrated into smaller subatomic particles like positrons and neutrinos. The cosmos will have no stars, no galaxies, and no planets. Just a sparse, cold mist of particles spread thinly across an infinite void. In this far future scenario, time continues, but its meaning becomes almost irrelevant. Without events, movement, or structure, time becomes an abstract concept. Decay and entropy, the gradual breakdown of order, would be the only processes still occurring, albeit at an almost imperceptible rate. The universe might continue expanding forever, growing colder and more dilute as time marches on. Alternatively, some theories suggest that dark energy, the mysterious force driving cosmic expansion, might eventually weaken or reverse, but at 10 quintillion years, there's no sign of such change. If the universe is so lifeless, does that mean life is impossible? Surprisingly, not entirely. Some physicists hypothesize that life could adapt to these extreme conditions. Hypothetical post-biological life forms might exist as patterns of information encoded in particles or fields sustained by quantum processes rather than chemical reactions. Such life would be unimaginably alien, operating on timescales so slow that a single thought might take billions of years. These beings, if they exist, would not resemble anything we recognize as life, but they could theoretically survive in this bleak, entropic landscape. The role of quantum mechanics, a flicker of hope. Quantum mechanics, the strange rules governing the smallest particles, introduces a flicker of unpredictability into this otherwise static future. Quantum fluctuations might occasionally create tiny pockets of energy or matter. Some theories suggest that over an unfathomably long time scale, These fluctuations could give rise to new universes through a process called cosmic rebirth. If true, this could mean that our universe's death isn't the end, it's simply part of an infinite cycle of creation and destruction. But these cycles would occur on timescales so vast that even 10 quintillion years seems like a fleeting moment by comparison. What about you, the time traveler? Let's turn the focus back to you. If you somehow traveled 10 quintillion years into the future, your survival would depend on technology far beyond anything we currently possess. You'd need to bring your own energy source, as the universe would offer none. Your spacecraft or protective system would need to shield you from near absolute zero temperatures and prevent your atoms from being scattered into the void. Assuming you succeeded in surviving the journey, what would you experience? Most likely overwhelming silence and darkness. The night sky as we know it would be gone, replaced by an empty expanse devoid of stars or galaxies. The only illumination might come from the faint afterglow of ancient particles colliding in the distance. Lessons from the end of time. While imagining such a distant future might seem bleak, it also offers profound lessons. The story of 10 quintillion years teaches us about the impermanence of all things, even the universe itself. It reminds us of the incredible beauty and rarity of our current moment when the cosmos is teeming with light, energy, and life. We're living in what some cosmologists call the golden age of the universe. Stars shine, planets thrive, and the conditions for life exist. Knowing what lies ahead underscores just how precious this fleeting moment is. Conclusion. A journey worth imagining. Traveling 10 quintillion years into the future may be an impossible fantasy, but contemplating it expands our understanding of time, space, and existence. It forces us to grapple with the ultimate fate of the cosmos and our place within it. Though the distant future may seem cold and empty, it's also a testament to the incredible journey the universe has undertaken since the Big Bang. So what if you traveled 10 quintillion years into the future? You'd witness the final whispers of a universe once full of life and light, now reduced to particles adrift in the vastness. But in contemplating that distant horizon, we gain a deeper appreciation for the brilliance of the here and now.